Hello there, all you trig students, and we're back again to talk about a little bit more ideas behind the inverse trig functions. I can't overemphasize how important it is for you to have studied and learned the definitions of arcsine and arccosine that we discussed in the previous video. So let me give you a little idea of the kinds of questions and the kind of thinking that we have to do around inverse trig functions. So here's a question. Suppose we want to find the sine of the arc cosine of, let's say, a half. Okay, so let's take a second and think about this. Remember, this represents an angle. And that angle has to be between 0 and pi. And the significance of that angle is that the cosine of that angle is equal to a half. And we know that the angle between 0 and pi, whose cosine is a half, is pi over 3. Right? Got to know that unit circle. You've got to know the unit circle. And so what we see is that the arc cosine of a half is pi over 3. And the sine of pi over 3 is, do you remember? Square root of 3 over 2. So there's our answer to this question. Okay, so now let's look at a slightly more challenging question. And let's ask the question, let's see, what is the sine of the arc cosine of 2/3? Okay, so what makes this question different from the previous one? We have no idea what that angle is. There's nothing nice, no nice angle whose cosine is 2/3. However, here again, we know that that angle is between 0 and pi, and we know the cosine of that angle is 2/3. So it has to be an angle in the first quadrant, right? And so we call this whole angle right here, let's just call it theta. And we draw a right triangle. And here's theta. And what's the significance of theta? The cosine is 2/3. And what's cosine? Adjacent over hypotenuse. So what does that make the opposite side equal to? Opposite theta. So that's a simple application of the Pythagorean theorem, and we can find out that this side is the square root of 5. So therefore, the sine of arc cosine of 2/3, which is the sine of theta, we just look at our triangle, and sine is opposite over hypotenuse. And so the sine of the angle whose cosine is 2/3, we can see from our little picture, is equal to the square root of 5 over 3. Alright, so these two problems are the basic kinds of questions, and you really do need to make sure that you master those. Let's move on a little bit. So let's look at a different type of question. Let's bring in tan. Let's suppose we're talking about the tan of the arc sine of minus 3/5. Okay, so we know that this is an angle. And we know that that angle has to be between minus pi over 2 and pi over 2. And since the sine of that angle is negative, this angle right here, this representation of an angle, must be in the fourth quadrant. And so what that tells us is that when we take the tan of that angle, which is in the fourth quadrant, our result has got to be negative. And once we take care of that, the SIGN, the sine, we can just proceed with this as we did before. So let's call this angle as we did theta. Let's draw a triangle. right triangle. Here's theta. We've already taken care of the, I always have to spell it out, the SIGN. So now all we do is we look at this triangle where the sine is just 3/5, and that forces this side, the adjacent side, to be 4. And so tan is opposite over adjacent. So opposite over adjacent is going to be what? Take a second and tell me what you think it is. Did you get it? Remember, tan is opposite over adjacent. So tan is going to be minus 3/4. Alright, so let's look at one more. Let's look at what I call my favorite question in trig. This is the question that helps me understand if a student truly gets trig. Okay, so here it comes. And I think that this question truly examines how well the basic definitions of trigonometry are understood. So ready for it? Seems kind of simple. Arcsine of the sine of 2. Okay? Take a few minutes and think about that. Now, how many of you thought that the answer is 2? Right? Sine and arcsine are inverse functions, and so usually inverse functions cancel out, and the result will be 2. But, and this is the excuse me, this is the really big but. Remember what arcsine is. Arcsine is an angle, and that angle has to be between minus pi over 2 and pi over 2. So anytime that you ask what is the arcsine of something, that angle has to be between minus pi over 2 and pi over 2. And does 2 satisfy that condition? Heck no, 2 is bigger than pi over 2. So that's what makes this such an interesting question. So let's try to remember exactly what we're looking for. And let's see if I can write it down. Remember that arcsine of the sine of 2 is the angle between minus pi over 2 and pi over 2, whose sine is sine of 2. Alright? So this one really requires that you just keep looking at that, keep reading this, and truly understand what's going on. So take a break, press pause, and see if you can think about how this is going to work. So as always, it really helps to think about the unit circle. Let's see if I can fit it in here. So here's the unit circle, and 2 is somewhere over here. And the coordinates of 2 are cos 2, comma, sine 2. Now, what am I asking for in this question? Alright, I've written it down. It's got to be an angle somewhere between minus pi over 2 and pi over 2, whose sine value, in other words, whose y value on this unit circle, is the same as the y value right here. So what I can do is simply go over to here. And this length right here is the sine of 2. So if I keep going across, this value here has the same y value. In other words, this y value is sine of 2, this y value is sine of 2. And so what I need is to know what is this length. So here's what we do know. We know that from 0 to here is equal to 2. We also know that this distance right here is pi. So therefore, this length is pi minus 2, which means this length must be pi minus 2. And that's our answer. Pi minus 2 is an angle between minus pi over 2 and pi over 2. And that's the angle between, right, between minus pi over 2 and pi over 2, whose sine value, whose y value, is equal to sine of 2. So keep digging into this and see if you really have mastered it. I hope you have, and we'll see you next time.